11.6 Similar figures. When we talk about similar figures, we're talking about a figure that can be created from another by using a similarity transformation. A similarity transformation is a sequence of dilations and rigid motions. Now remember, our rigid motions are our translations, reflections, and rotations. So when we talk about similar figures, we're talking about figures that have the same shape, but not necessarily the same size. These two triangles here are similar, meaning they have the same shape. We know they have the same shape because their angles are congruent. So angle B is the same as angle E. They have the same measure. We can also see that because angle B has a single line angle mark, as does angle E. Angle C and angle F both use a double angle mark, meaning that angle C is congruent to angle F, and likewise for angle A and D. And here is below is how we kind of denote it. Remember using that congruent symbol. Now, also with similar figures, they are not necessarily the same size. But what is true is that their side lengths are proportional. So AB is proportional to side length DE, and it is the same proportion that BC has with side length EF, and likewise for AC and DF, which you can see here. Okay, their side lengths are proportional. If AB is half the size of DE, then BC is going to be half the size of EF, and likewise AC is going to be half the size of DF. Okay, let's see how we can determine whether triangle ABC and triangle JKL are similar. So first, I would look at side length AB and notice that side length AB is 3 units long. And then side length of JK is 6 units long. So it looks like JK is twice as big or twice as long. Now, if we look at side length BC, it's also 3 units. And looking at KL, it's 6 units. Again, 2, right? Twice as big. So it looks like our scale factor then, our K is 2. So if we multiply both our X and Y values by 2, all the way down here, right? We should end up with our J, K, and L. So 0 times 2 is 0. 3 times 2 is 6. 3 times 2 is 6. And then 0 times 2 is 0. So if we look here, these should be the coordinates of our similar triangle. So if we look at 0, 6, that's where J is. That's what we expected. 6, 6 is where K is, and 6, 0 is where L is. Okay, now it is time for you to write in your notes. There are just 2 fill in the blanks. Okay, next we can describe a similarity transformation if we are given 2 similar figures. So below here we have a red figure and a blue figure, and they are similar. So we're going to try to compare these two and decide how we can dilate and then transform the red one to become the blue one, or vice versa. Okay. So first thing to note, if you look at these two figures, this bottom length and this length here, how do they compare? Well, this one's 2 units and this one is 4 units. So comparing the side lengths right here, step 1, we notice that the blue figure is half the length as the red figure. or the red figure is twice the size, right, of the blue figure. Okay, so here are the coordinates of my red figure, and I am going to then use a dilation or a scale factor of 1/2 so I can get it down to the same size as the blue one. Okay, so if we multiply the red figure's vertices by 1/2, we end up with this: 2 comma negative 1, 4 comma negative 1, 2 comma negative 2, and 3 comma negative 3, which then means our shape now looks like this roughly. So now you can see once we've dilated it, all we have to do then is what? We need to reflect it in the x-axis. When we reflect it in the x-axis, we know that our x values are going to stay the same and our y will change, which means it's going to go up over here. So to describe this similarity transformation, 1, we have a dilation of 1/2. 2, we have a reflection in the x-axis. Okay. Now it is time for you to do one practice problem. Okay, for this practice problem, we are going to look at the red triangle and the blue triangle. And we can see that we could dilate the red figure using a scale factor 2, and then we could translate it either left or right or up or down, and or up or down. Okay, so the first step that you want to do on this one is you want to dilate the red figure, the red triangle, using a scale factor of 2, meaning you take the red's vertices. So for this one, it'd be 5 comma 5, 6 comma 4, and 7 comma 5. Okay. You want to multiply those each by 2. And then you will get your new coordinates of your dilated figure. And then you're going to have to translate it left or right, up or down. And that is the end of 11.6.